Okay, in chapter 15.3, we're going to use the signs test to see if something's, if to use hypothesis testing on medians. Okay. And StatCrunch actually does it, but the one thing they don't do is they don't do it from summary. And so, as you can see, your data is summarized here. That we know, or we think the median is 8. That's the null hypothesis. But when we looked at our data, we see there's 12 minus signs, 12 data points less than 8 and 5 greater than 8. Okay. So we want to test this hypothesis at the 5% level of significance. So basically the way that we do this is we figure out what our n is, right? Just like with the runs test, there's a small case and there's a large case. So here, if there's 12 minus signs and 5 plus signs, that the data is, there should be 17 points of data. I guess that doesn't count if there's a lot of data points right on 8. But this is definitely a small case. I think what is it? I think the 30 is the larger case if there are 30 data points. Not quite sure on that. I have to look back at the book. But 17 is definitely a small case. And then we want our test statistic, which is going to be what the book calls K. And that just is, it depends on which way you're testing it, right? Here we want to see if the median is less than 8. There's 12 data points less than 8, and there's only 5 greater than 8. We're expecting, if 8 is the median, to have an equal number on each side. And so the more equal these are, the less likely we are to reject the hypothesis, the null hypothesis that the median is 8. Here, there's a lot on the low side of 8. So we have our alternate hypothesis is that the median is less than 8. So what we want to do now is, and these 12 minus signs are what we're preoccupied by, but K is actually defined by the other side. It kind of helps to, one, read the book really carefully on how K is defined, but also, if it helps, you can just think K is always the opposite of what I'm kind of looking at, right? I'm worried about these 12, but K is going to be 5. It's the opposite. Because likewise, there's just two ways to state this. If you're expecting, if your null hypothesis is that the median is 8, you're expecting an equal number over here. So one way to say that is that we're expecting this to be not so large and this one to be larger than it is, right? It should be closer to the middle of 17, right? Or 16, or 8.5, which is not the case here. But is it so extreme that we're going to reject the null hypothesis at a 5% level of significance? Well, we have to take our test statistic K, which is 5, right? And we have to take it over to the table, which happens to be, these are the critical values for the science test. Notice we're not using a p-value method like we have through much of the semester. We're using a critical value and a table approach. And so we have to know the number of data points, and that was 17, I think, in this question. Yeah, 17. And we are doing a one-tail test at 5%, right? That's the significance. So our critical value looks to be 4, okay? Now, what that means is if our K, right, is less than 4, then we're going to reject, right? There's too few high values above the median if there's 4 or less, right? So this is 5. So we don't, it's close, it's suspicious, right? But it's not something that we would reject the null hypothesis for at a 5% level of significance. So I hope that helps on this one. That's why the final answers do not reject the null hypothesis, because the test statistic is greater than the critical value. The critical value was 4, right? The test statistic is 5. So I hope that helps a little bit on this.